2, 1. All right, so here we are. Quadratic formula. We took this guy over here, 1x squared, 2x, and 1, and plugged in our a, b, and c values in here. Wherever we have an a, we plugged in a. Wherever we plugged in, or had b, we plugged in b. B was here and here and here was our 2. C, 1. Now there are two parts to this quadratic formula. You might notice the 2a, negative b over 2a, that's kind of our vertex type of deal, okay? This thing inside here is going to tell us about our y-intercept, or I'm sorry, our x-intercepts. If the thing inside here, the b squared minus 4ac, after you plug in your numbers, gets you a positive answer, so like 1, 2, 3, 4, 5, 6, you have 2 x-intercepts. If you get a negative number out of here, you have 0 x-intercepts. And the reason for that is because now you've got a negative under a square root over here. Breaks math, right? 0, you're going to have one solution. And that's because when you take the square root of 0, adding it and subtracting it doesn't really matter. So you're going to get negative 2, like we got here when we try this out in a second. So this is the number of x-intercepts. So here's an example of a parabola that has 2 x-ints. Here and here. Vertex there. Here's an example of a parabola that has 0 x-ints. Let me erase this.
Ooh.
Nothing, right? Here's an example of a parabola that has 1 x-int. Can anybody think of what the example is?
It's just the one on the one side.
You go through one of the things
Just one vertex
and then
on one side.
stop.
So like negative 2. That's it, right? Yeah.
Where the vertex is our x-int, right? That's it.
Stop.
Okay, so in this one, how many solutions do we get in the discriminant? 2 squared is 4 minus 4, right? 0, so we only have one solution. That makes sense because all of this is just going to be 0. What's the square root of 0?
0.
It's 0.
That's nothing.
Negative 2 plus 0 is negative 2. Over 2 is going to get us negative 1. Negative 2 minus 0 is still negative 2 over 2, which is going to get us negative 1. So we only have one answer here, negative 1 for our x. They're both the same thing. So when we plug in negative 1 to our graph, what's going to happen is you're going to get this, negative 1x and 0y. And you can check that when you plug in negative 1 up here. Negative 1 squared is 1, minus 2 is negative 1, plus 1 is 0. So our intercept is here. And it makes sense that y is here because whenever you have an intercept, y equals 0 for this point. So in this case, we only have 1, and our intercept's here. It's negative 1, 0, which means this is also our vertex. You can confirm that. Negative b over 2a, right?
So pretty much the y-intercept's always going to be 0.
Always. Always going to have 0 for the y-coordinate, right? Because that's the definition of an x-intercept. So again, because you messed up some of the wording there, this is an x-intercept. Okay, it's going to, where it intersects our x line, not our y line. Y-intercept is y equals mx plus b, right? Okay, where it intersects our x line, y is going to be 0. And this is going to be whatever you get here. Could be 2 options, could be 1, could be none. In this case, it's just 1. I keep dropping that. So let's graph it now. Like the actual thing. So graphing this guy over here. How do we graph this? Do you guys know? It's been a while.
Well, it's 0, comma, no, negative 1, comma 0.
Negative 1 comma 0 was our intercept slash vertex, right? So we got a point there, that's cool. How do we get other points?
Make it 2.
Gotta make a table. X, Y. What values are we going to use for x?
Negative 2, negative 1, 0.
Negative 2 squared is 2. Plus negative 2 times 2 is negative 4. So that's 2 minus 4 is negative 2. Plus 1 is negative 1. So negative 2, negative 1. Negative 1. Did I do that math right? Negative 2 squared is 4. Minus 2 is 2. Plus 1 is 3. Knew it. Always check your math. Negative 1 squared is 1. minus 2 is negative 1, plus 1 is 0. Hey, look, that's our guy. That's kind of nice. Doesn't always happen that way. 0 squared is 0, plus 0, right, is 0, 1. So 0, 1. This is 1. We're going to plug it in. 1 squared is 1, plus 2 is 3, plus 1 is 4. So where we got 1, we got 4. And it's going to look a little weird because my graph isn't perfect, right? There's not the same amount of space in between each of these intervals. 2 squared is 4, plus 4 is 8, plus 1 is 9. Way up here, right? So at 2, it's somewhere up there. That's the graph of our parabola. Cool. So we've used the discriminant to find the number of solutions. We've used the quadratic formula. We've graphed quadratic inequalities, basically. Because all a quadratic inequality is just, is it dashed or not, right? If I change this to an inequality instead of an equals. We know it's going to be a bolded line because it's got the line underneath here. It's less than or equal to. So it includes what's on this line. Using this, we need to figure out which way to shade. So let's try a point and plug it in and see what happens. If I try this point, let's try this one right here. What is the coordinate of this point?
Where?
0, 0.
Oh.
Let's try it. For x, 0, right? So we get 0 squared plus 2 times 0 plus 1 is greater than or equal to, greater than or equal to 0, because 0 is our y value. Is this true? 0 is greater than or equal to 0 plus 0 plus 1.
No.
This is true. 0 is less than or equal to. Did I say greater than?
Yeah.
I did, my bad. 0 is less than or equal to 1. Is that true? Yeah, so that means this point exists with this statement. So all the area out here, we would shade. Because that's where our point was. It was outside.
Oh.
You see why it was true?
Yeah.
0 is less than or equal to 1. It's definitely less than 1.
Do I have to shade on the final?
You'll have to pick the graph that's shaded,
Oh.
right? So that's a quadratic inequality. I just kind of lump that in at the end. It's the same thing as a regular quadratic. Chapter 10, adding and subtracting terms, multiplying binomials, factoring quadratic equations. Let's do that real quick. Do you want to see me adding and subtracting terms? I didn't think so. Multiplying binomials. FOIL, do we understand FOIL?
Yeah.
First, outer, inner, last.
Yeah.
What about factoring quadratic equations?
Yeah.
You know how to factor?
Yeah.
Feeling
Do
good?
like one problem.
Okay, let's factor one problem, okay? Get rid of all this. And then we're done. We're out of here.
Yay! Food!
2.5 hours. Going by fast.
You could have left at any time.
It's good we stayed because I wouldn't have a ride home.
I live
Oh.
20 minutes away.
I needed to learn this again.
Me
Yeah.
too.
That's why I'm doing this. All right, so factoring a quadratic. Let's use the classic quadratic x squared plus 2x plus 1.
That's just x plus 1, x plus 1.
All right, so we're factoring into binomials, right? So 2 terms and 2 terms.
X and x.
What times what gets us x squared?
X plus something times
What times what gets us this?
1.
Could be positive 1, could be negative 1.
2.
We want to get to this to add up to get this though. So if it was negative and negative, it would be negative 2. We want a positive 2. So this should work out. Let's check it by foiling. X times x is x squared. Ooh.
Plus 1x plus 1x plus 1.
X times 1 is positive x. 1 times x is positive x. 1 times 1 is 1. Combine like terms, right? This is adding and subtracting terms, right? X squared plus 2x plus 1. Did we start with that? Yes, so we must have factored correctly. We didn't change anything, we just wrote it differently. Cool. You want to try another?
Yeah.
Harder one.
Harder one, okay.
Hard one.
Let's try something with an a value other than 1, okay?
Or with a negative.
Or a negative.
Or negative. We can do both.
All right, so let's do negative 2x squared.
Oh.
I gotta think about this one.
Your hands are black.
I know.
Why?
Marker.
Oh!
Careful. Here, let me make one up over on the side. Don't look.
Remember when Mr. V would write on both boards?
Start this like pull it out.
And then go back. How did he ever use that?
I was so confused.
Yeah, literally he was starting here, working
Oh.
here,
And then we go back to that one.
Oh, is that what you guys want? That's funny. You're not funny.
Nice.
Wait, Alyssa, we're in the
Negative 2, here we go. Negative 2x squared plus 8x minus 6. Let's factor this.
negative 1. I'll go to the gym.
What times what gets us negative 2x squared?
1 and 1.
Negative 1 and 1 does not get us that.
Negative 2 and 1. So negative 2x.
Negative 2x and regular x. Let's try that.
Whoops.
We got options, right? Could do the reverse. We could have negative x and positive 2x here. We got to figure it out. So what times what gets us negative 6?
Negative 3 and 2.
Got some problems here, right? Negative 3, positive 2 could be either or. Let's see if this works. Does negative 3 plus 2 times negative 2, negative 4, negative 3 plus negative 4 get us positive 8? No. But let's show you anyway. This times this is negative 2x squared. This times this is negative 4x squared. 4x. Why did I say squared? 4x. Negative 3 times this is negative 3x. Negative 2x squared minus 7x minus 6. Is that what we started with?
No.
So that doesn't work.
Negative 1.
What we need something here and here that adds to get to 8.
Negative 1 and 6.
Let's try it. Do we see why we're trying negative 1 and 6?
Yeah.
Because they multiply together to get that. Let's try it. Negative 2x times x is negative 2x squared. If you didn't get that, you really goofed. Negative 2x plus 6 is negative 12x. Negative 1. Did I do that right? Yes. Negative 1. This isn't going to get us anywhere, is it?
No.
Nope.